Good morning. Let us study in this class what are the factors affecting color, how the selection rule is mathematically obtained by considering one-dimensional box. That is, with reference to one-dimensional box, we will show that in this class. Let us consider an electron in one-dimensional box. Since the electron is permitted to move from 0 to A, the electron is bound. Since the electron is bound, the energy levels obtained are discrete. The energy levels are discrete. These are the energy levels for particle in one-dimensional box. We have already seen. The energy levels are discrete since the electron is bound. Suppose if there is no boundary, if the electron is free to move, then the energy levels are continuous. The energy levels are continuous. Okay. Now, on absorption of suitable light or energy of photon, the electron may undergo transition from lower level to higher level. Okay. Let us consider the transition. Psi n prime equal psi n prime to psi n. N prime is the ground state. N is the excited state, En prime to En. The transition energy is obtained by using the Bohr relationship delta E equal to E2 minus E1, that is En minus En prime. For particle in one-dimensional box, we have already seen the energy equal to n square, energy of nth level equal to n square h square divided by 8ma square, where a is the length of the box, m is the mass of the particle. Therefore, on substituting, you will get this expression. The frequency of the electronic transition is calculated by using this Planck equation, delta E is equal to h nu, therefore nu is equal to delta E by h. Since we know delta E, you substitute here, the frequency of the electronic transition can be calculated. Similarly, the wavelength of the transition is obtained by using this relation c is equal to nu lambda, lambda is equal to c by lambda, where c is the velocity of light. Okay, therefore lambda equal to 8 mca square. On substituting, you will get this relation n square minus n prime whole square h. Therefore, lambda is directly proportional to mass and lambda is directly proportional to the square of the length of the box. A is the length of the box. As length increases, as box length increases, the lambda increases. As length of the box increases, lambda increases. By adjusting the length of the box, it can be made to absorb light in the visible region. It can be made to appear colored. For example, let us consider ethylene molecule. In ethylene molecule, it is considered as particle in one-dimensional box problem. There is a pi electron. Okay, the length is L. In the case of ethylene, it is colorless because it absorbs UV light. Whereas in carotene, see, there is an extensive conjugation, therefore delocalization of the pi electron. The length of the box, as length of the box increases, there is delocalization increases, therefore it absorbs light in the visible region. See, by suitably adjusting the length of the box, it is made to observe in that, it is made to be colored. It becomes colored. Okay, now let us see the selection rule, how it is mathematically obtained. You know already 1 to 2 is allowed because one step, delta n equal to plus or minus 1. 1 to 3 is not allowed because delta n is not equal to plus or minus 1. How it is proved, how it is mathematically obtained? See, not all the transitions are allowed. The transition is not all the transition is allowed. Okay, because the transition probability, because it depends on the transition probability. Because it depends on the transition probability. If the transition probability 1, 2, 3 is 0, then there will be no transition. The transition is not permitted because of the transition probability, which depends on the magnitude of the transition dipole moment integral. This is electronic dipole. The transition is called electronic dipole transition. Therefore, the transition probability depends on the transition dipole moment integral. What is dipole moment? For a molecule, the dipole moment is calculated using this relation I have shown in the last few slides. Please watch that. Therefore, mu equal to E into D. D is the distance between X. D is the distance between the two atoms in a molecule. Therefore, E into D. That is, this is nothing but the average distance. Average X is calculated by using the average value theorem or expectation value theorem we have studied in the postulates of quantum mechanics. For particularly one-dimensional box, the wave function is known. This wave function is known. Okay, therefore, one substituting n prime here, n prime, n dx. If this transition moment, listen carefully, if this transition probability or transition moment integral is not equal to 0, then only the transition is allowed. If the transition moment integral is equal to 0, the transition probability is 0, therefore there will be no, transition is not allowed or permitted. How the integral is evaluated? For example, 1, you put 1 here, n prime 1, 2 here, and you evaluate the integral, it is not equal to 0, therefore the transition is allowed. Suppose you 1 and 3, here 1 and 3, on evaluating the integral, this integral becomes 0, the integral vanishes, therefore the 1 to 3 is not at all allowed, is not permitted. This is true, this is evaluated mathematically. Therefore, the following selection rule, the selection rule for particularly one-dimensional box states that if n plus and n prime, the sum n prime plus sum, this is the difference, sum or difference in quantum numbers, n prime and n are quantum numbers. If the sum or difference in quantum number is odd number, then the transition is allowed. Suppose if n prime plus or minus n is given number, if both are given, then it is permitted. I have shown the mathematical derivation of this integral and also a few examples to show this. Okay, you see that kindly. We know the dipole moment of a molecule, for example, HF molecule. The dipole moment is calculated by using this relation mu equal to E into D, where E is the charge on the atom, the magnitude of the charge on the atom. D is the distance between the two atoms in a molecule. D is also called X. Similarly, the transition moment integral E mu equal to E into D or E into X. Okay? E into X. The average value of the transition moment, electronic transition, the average value of X is determined by using the average value theorem or expectation value theorem we have studied in the postulates of quantum mechanics earlier. Therefore, integral psi x cap psi dx. Therefore, the transition moment integral is mu equal to E electronic charge on the electron. This is nothing but charge on the electron integral psi n prime x cap psi n dx. For one-dimensional box, for electron in a one-dimensional box, the length of the box is equal to A. That is, the length varies from 0 to L is also called X. So in the expression, the average value or the transition moment integral, that is psi n prime x cap psi n dx, the limit is 0 to A. Let us consider theta equal to pi x by A. Let us simplify this mathematical equation to evaluate the integral. If the transition moment integral, this is called transition moment integral, if the transition moment integral is not equal to 0, then only the transition is permitted or allowed. So let us evaluate this integral. Consider theta equal to pi x by A. Okay, for x equal to 0, you put x equal to 0, theta equal to 0, and then the limit. Let us find the limit in terms of theta. X equal to A. When you put x equal to A here, A cancel, therefore theta equal to pi. X equal to, therefore, on rearranging this equation, x equal to theta A by pi. Okay, let us differentiate this equation. dx equal to A by pi d theta. Now let us substitute dx theta in the equation number 1. Therefore, 2 by A integral 0 to pi sin n prime theta, theta is x cap or x bar, position vector, theta A by pi sin n theta A by, this is dx equal to A by pi d theta. From the above, the equation 5 is obtained by using the trigonometric formula for this integral sin n prime theta into sin n theta into theta d theta, it can be written 1 by 2 integral 0 to pi cos n minus n prime theta into theta d theta minus same, you write the same n except n minus here n plus n prime. Okay, now this 2 get cancelled, therefore a by pi square. This integral is called I1. This integral is called I2. Where I1 equal to integral this. Okay. On evaluating this integral, it is found to be minus 2 n minus n prime whole square. See, this I1 is equal to 0 mathematically. When I1 equal to 0, if n minus n prime is even number. I1 is not equal to 0 when n minus n prime is odd number. You just write this. You need not remember this also. Just write this. The integral I2 is evaluated and found to be minus 2. The same result minus 2 n minus here n plus n prime whole square. Similarly, I2 equal to 0 only when if n plus n prime is an even number, where n and n prime are quantum numbers. Where n and n prime are quantum numbers, I2 is not equal to 0 only when n plus n prime is an odd number. From the above, it shows that the integral does not vanish, does not become 0 if n plus or minus n prime is an odd number. If the transition moment integral is equal to 0, then the transition is not allowed between the two quantum numbers, n and n prime. The transition moment integral is not 0
only if the sum and the difference between the two quantum numbers is an odd number. Let us see, for example, with an example, maybe it is easily understood. For example, n prime, the transition takes place, the electronic transition takes place from n prime 1 to 2. Therefore, n plus n prime equal to 2 plus 1 equal to 3 odd number. And similarly, n minus n prime equal to 2 minus 1. That is equal to odd number. That is the condition, the transition, if n plus or minus n minus is equal to odd, then the transition is allowed. You know the transition is plus or minus 1. Delta n equal to plus or minus 1. Here 2 minus 1. Therefore, this is allowed. For example, in another case, we will see next. In another case, the transition takes place from 0 to 2. You know that delta n equal to, in this case, 2 plus or minus 2. So this is not allowed. We have proved experimentally from the transition moment integral. The transition moment for this n plus or n plus n prime equal to 0 to plus 2, therefore even number. Similarly, n minus n prime 2 minus 0 equal to 2, even number. If the sum and difference is equal to even, then the transition from 0 to 2 is not allowed. Okay, this is well known, you know that. So we have thus proved mathematically, we have obtained mathematically the transition rules, that is selection rule.